everyone. In this video, we will learn about the chemical properties of haloalkane. Alright, in haloalkane, we will have halogen, the elements in group 17 as our substituent. And basically, the IUPAC nomenclature for haloalkanes follows the basic rules as described in alkanes. When halogen become the substituents, it will named as fluoro, chloro, bromo, and iodo. Take note how to spell the word fluoro, chloro, bromo, and iodo so that your IUPAC name will be written correctly. Let's look at this example. I have this compound. So from this compound, we can see that our longest chain has 4 carbon with bromine as our substituent and methyl group as substituent. So as we learned before, when bromo and methyl, referring to the alphabet involved, B and M, B will come first, so it will become 1 bromo 2 methyl butane. For the second example, I have this compound. So we have also 4 carbon as longest chain. And we have fluoro as our substituent. So the IUPAC name here is 2-fluorobutane. And the last one, I have iodine as my substituent. And we have 4 carbon as longest chain. And the name will become 2-iodo 2-methyl butane, as I come first before M. Okay, now look at the chemical reaction in haloalkane. So I will use this very simple example, 2-fluorobutane. So as we already learned in alkene, we will have elimination of haloalkane under the reaction of dehydrohalogenation to produce an alkene. One as minor product and one as major product follows the Zetsef rule. Okay, now for this session, we will look at other chemical reaction in haloalkane, which is nucleophilic substitution, which involve these 7 reactions. Okay, we can see a reaction with sodium hydroxide, reaction with alkoxide ion, reaction with excess ammonia, reaction with KCN or NaCN, reaction with alcohol, reaction with acetate ion, and lastly is reaction with H2O. This is what we call as nucleophilic substitution. And the second one, from our haloalkane, we will see how is the formation of GRIGNARD reagent, which is very useful in the formation of these 3 compounds, alkane, alcohol, and carboxylic acid. Now we will start with nucleophilic substitution in haloalkane. I use the same example as previous example, 2-fluorobutane. Now I want you to focus, and you may refer to the handout that I already attached in your Google Classroom as your guideline, and you can also complete that mind map while you learn through this video. Okay, firstly, I have this 2-fluorobutane, and we will do the nucleophilic substitution in haloalkane. So why it is named as substitution? Because we can just substitute this halogen with other compound, or as this is a haloalkane, this carbon which attached to fluoro, so fluorine is more electronegative than carbon, this carbon will become partially positive while this fluorine will become partially negative. So this site of reaction carbon has become an electrophile, while the one that will react with the electrophile is the nucleophile. Now our NaOH is our nucleophile, and this nucleophile will be react with this haloalkane, and it will be substituted with this fluorine. Okay, now look at how to draw the structure. Okay, now our carbon has 4 carbon. You just copy back this 4 carbon, but the fluorine now has been substituted with OH group. Where comes the OH group? It is from the sodium hydroxide. This is our nucleophile that will be substituted with the halogen in this compound. And we will have our side product F minus, because F minus now has been a living group. Ini kita panggil sebagai living group because dia out. Yang masuk adalah OH. Where come the OH? It is from the NaOH. Okay, now look at the second reaction of nucleophilic substitution. We will react with our alkoxide ion. Where is the alkoxide ion? This is our alkoxide ion. OCH3. This is sodium methoxide. So methoxide here is an alkoxide ion. Alright. So now this alkoxide ion or methoxide ion has been the nucleophile that will be substituted with this fluorine. So now look at the product. Same as previous reaction, we just copy back our carbon, 4 carbon, but now F has been substituted with this alkoxide ion, OCH3, and F minus now being the living group. So this is our product when our haloalkane react with alkoxide ion. Okay, sometimes the question just give you the ion. So dia hanya bagi react with OCH3 minus. Okay, or OCH2 CH3 minus. Okay, depend pada soalan. But in this question, in this case, saya gunakan alkoxide with 1 carbon. That's why yang masuk adalah OCH3 and F minus become the living group. Okay, next reaction is the reaction of haloalkane with the excess ammonia. So same as previous reaction, you just substitute this halogen F with NH2. Okay, with NH2 dia akan gantikan dengan F, and now F minus will become the living group. Okay, reaction with KCN or NaCN, we substitute F or halogen here with Cn minus. Okay, and F minus as living group. Next is reaction with alcohol. Reaction with alcohol, our nucleophile is OCH3, same as our alkoxide ion. Bezanya sekarang ni adalah this one as strong nucleophile while this one as weak nucleophile. But yang akan masuk sama juga. Dia alkoxide ion yang akan masuk. So kita akan dapat OCH3 will be substituted with fluorine in this reaction and F minus as our living group. Next is reaction with acetate ion. So I use sodium acetate as the example. So where is the acetate ion? Here is the acetate ion. CH3COO minus. So this will be your nucleophile which will be substituted with the halogen here. So we will get the product is OC double bond OCH3 will be substituted with our halogen and F minus as our living group. Okay, and lastly is reaction with water. Now water, we have OH minus as our nucleophile and F will be substituted with OH, and we will have F minus as our living group. Alright. So class, can you fill the mind map that I have prepared to you? If you complete the mind map, you can try with another example using the same reaction to see that either you can write the product or not. Okay, next we will look at the GRIGNARD reagent. General formula is RMGX. Reactant that will be involved in the formation of GRIGNARD reagent is our alkyd or Ri halide and magnesium with the condition of dry ether. So for example, this is general formula of our GRIGNARD reagent. We have Rx, our haloalkane, react with Mg, magnesium, in the presence of dry ether, so we will have RMGX as our GRIGNARD reagent. Okay, so the GRIGNARD reagent is very useful compounds, it can produce three compounds, which are alkane, alcohol, and also the carboxylic acid. Now, let's look at the example. I use the same example, 2-fluorobutane. Okay, when we treat the haloalkane with magnesium in the presence of dry ether, we will get our Grignard reagent, MgF. So when we react our Grignard with H2O or hydrolysis of Grignard, we will get our alkane. When we react our Grignard with carbonic compound followed by acidic hydrolysis, we will get alcohol. And when we react our Grignard reagent with the carbon dioxide followed by H3O+, we will get a carboxylic acid. Now look at the example. How is the formation of alkane from Grignard reagent? So we have haloalkane. I still use the same example. 2-fluorobutane. React with magnesium in the presence of dry ether. So the fluorine here will be substituted with MgF. So this one we call as Grignard reagent. When our Grignard reagent is treated with H2O or hydrolysis of Grignard reagent with H2O, we will get an alkane with the same number of carbon. Our Grignard reagent have 4 carbon, and when we do hydrolysis of Grignard reagent, we will have an alkane which also has 4 carbon. Okay, how is the formation of alcohol from Grignard reagent? Say I have this Grignard reagent. So firstly I have this aldehyde with 1 carbon, or name the general name here is formaldehyde, followed by acidic hydrolysis. This is how to write the reagent. Number 1, we have formaldehyde. Number 2, we have H3O+ or acidic hydrolysis. So I want to show you how to write the product. Please take note how to draw the product. First, we will draw the carbonic compound. Now we have 1 carbon, so we copy back this HCH, but now C double bond O already break and it will become OH group. This is from our carbonic compound with 1 carbon, and here attach the carbon or the chain from our Grignard reagent. So we have 1, 2, 3, 4 carbon. It is from the Grignard reagent, and this carbon will attach to this carbon, which is carbon that attached here is MgF. So we will have our product as primary alcohol when we react our Grignard reagent with the carbonic compound with 1 carbon or formaldehyde or methanol followed by hydrolysis. Okay, got it, class? Next, if I have Grignard reagent and I react our Grignard reagent with carbonic compound or aldehyde with 2 carbon followed by hydrolysis, how to draw the product? Same as previous product. First, you just have to copy back your aldehyde, CH3CH, but the double bond O here has break and become the OH group here, and at this carbon will attach the carbon that previously attached the MgF at this carbon. So just copy back your alkyl site from the Grignard reagent and attach it to this carbon. So we will have this kind of alcohol. We classify it as secondary alcohol. Okay, why secondary, why primary? Same as when we classify our carbon. Okay, we have to look at our OH group attached to what type of carbon. So this carbon is secondary carbon. This is secondary carbon. So OH attached to secondary carbon, we classify it as secondary alcohol. And the third one is reaction of Grignard with ketone. Okay, here is the ketone, C double bond O, followed by hydrolysis. Okay, first we draw the ketone, but the C double bond O already break and it become OH. And at this carbon attach the alkyl site from the Grignard reagent. So this carbon will attach to the carbon here. So we will have another type of alcohol, which we classify it as tertiary alcohol. Alright, class. So in this reaction, it is very important for you to know how to draw the product. just follow the way that I already teach you. First, copy back the carbonic compound with changing the C double bond O into COH and attach the alkyl group from the GRIGNARD reagent. This reaction is actually how to prepare your alcohol with the addition of number of carbon. So, contohnya asalnya you have 4 carbon, but you want to prepare your alcohol with more than 4 carbon. So, now dia dah bertambah bilangan carbon. Okay, same goes to this reaction, bilangan carbon dah bertambah, and this also we have extra carbon. And we can choose this way to prepare our alcohol if we want to produce primary alcohol, secondary alcohol, or tertiary alcohol. Primary alcohol will be produced when GRIGNARD reagent react with formaldehyde followed by hydrolysis. Secondary alcohol when we react our aldehyde with more than 1 carbon followed by hydrolysis, while tertiary alcohol will be produced when we react our GRIGNARD reagent with ketone followed by hydrolysis. Okay, lastly is the formation of carboxylic acid from GRIGNARD reagent. So, we have haloalkane. When we treat it with the magnesium in dry ether, we will have our GRIGNARD reagent. If we want to produce carboxylic acid from our GRIGNARD reagent, we just have to react our GRIGNARD reagent with 1 carbon dioxide followed by number 2 H3O+, and we will have our carboxylic acid with this MgF will be substituted with COOH. This is also one way to prepare carboxylic acid with extra number of carbon. Look at here, at first we have GRIGNARD with 4 carbon, but now we already produce a carboxylic acid with 1, 2, 3, 4, 5 carbon.